In this video, what we're going to do, instead of going from the state transition diagram to the transition matrix, we're going to go from a transition matrix to the state diagram. Alright, so what do we mean by that? What we're going to do is we're going to pretend that we were already given a P matrix. And I'm just going to fill it out sort of randomly. There we go. So here goes a transition matrix P. And what we're going to want to do is go from this transition matrix to a state diagram. So in this case, we can see that the number of states that we have is 4, telling us that when we draw our diagram, we want to make 4 nodes. So I'll just number them 1, 2, 3, and 4. And from here, we can start going through our matrix in order to fill in the probabilities for our diagram. And so again, we call this the state transition diagram. While this P matrix is the state transition matrix. Again, for this case, every Pij corresponds to the probability of going from state I to state J. All right. In one step. And actually, that's the important part here. This is a single step transition matrix, okay? But by default, we just call it the state transition matrix. All right, so let's go ahead and do this. Right away, what we're going to do is go through each row, and it will inform us about which arcs connect which of the nodes. So here, we see 0.5 in the first row and first column, so that tells us that 1 returns back to itself with 0.5 probability. We also see 1 connects with 3 and with 4 with 0.25 probability. But it does not connect with 2. Now when we look at 2, we see that there's a self loop here with probability 1. And so right off the bat, we should start thinking, well, state 2 is an absorbing state. For state 3, we see that with probability 0.3, we go to state 2. With probability 0.6, we stay in state 3. And with probability 0.1, we go to state 4. Now for state 4, we just look at this last row, and we see we get 0.5 and 0.5. Okay? So hopefully this gave you a quick example of how we go from a state transition matrix to a state transition diagram. And you should feel very comfortable going back and forth between these two. All right, so what I'm going to do is I'll quickly do another example. But if you feel like you got it, you can go ahead and skip. All right. What am I doing? Okay. So here goes a quick state transition matrix. We get 1/3, 2/3, 0, 0, 1/3, 2/3, 2/3, 0, 1/3. All right. And again, we're going to go through the same process. The first thing that we want to do is count how many nodes we have. In this case, we have 3 nodes. So we can draw 3 nodes, and we'll label them 1, 2, and 3. And we can start connecting them according to the probabilities we see in each row. So in this first row, we get 1/3 goes back to itself. 2/3 goes to 2. For 2, we get 1/3 goes back on itself, while 2/3 goes to 3. And finally, we have 1/3 and 2/3. All right. So in this case, we should note that we don't have any absorbing states. All our states are transient states. There's 2 ways we can tell that. First of all the self loops are less than 1, the probability. We only have an absorbing state if there's a self loop where the probability is 1. So in this case, all our self loops are less than 1, right? So they're 1/3, 1/3, 1/3. All right, so that's how we can tell from the diagram. And again, we can tell from the transition matrix because what we actually want to do is look at this diagonal here. Right? If we see a value of 1 anywhere in the diagonal, then we know that corresponding node is an absorbing state. Let's do a quick example of that. So I'm just going to edit this transition matrix just a little bit, and I'll do 1/3, 2/3, 0, 0, 1, 0, and then 2/3, 0, 1/3. All right. So right off the bat, I can tell that state 2 is an absorbing state. Okay? And that's because it has a 1 in the corresponding diagonal. Now, we can certainly draw the diagram. We get 1/3, 2/3, 1, and then 1/3. Oops. Yeah, 1/3 and 2/3. So here from this drawing, we see the case where 2 has a self loop with probability 1. And so here that tells us 2 is an absorbing state. All right. So hopefully with this video, you now feel comfortable going from a state transition matrix to a state transition diagram.